guys, so today we're going to talk about how to do the eccentricity lab. So let's get started. So I want you to read the introduction and objectives on your own, and I want to start here. Notice that you're given the equation for eccentricity, and you can also find it on your reference table, page 1. And the equation for eccentricity is distance between foci divided by length of major axis. So what we're trying to do today is, depending on the distance between two foci or two focus, one focus to the other, and your focus is always the sun, one of them, and also the length of your major axis, you can figure out the eccentricity of any orbit. And we're also going to look at how the shape of the orbit will change based on the distance between the foci. Okay, and for this you need a foam board, push pin, string loop, ruler, ESRT, and a sharp pencil. You can get the foam board from your teacher. Push pins and string loops should also be provided to you. Now it says tear up page 7, 8, and 9 of the slab. So if you look through your pages, this is page 7, this is page 8, and this is page 9. Okay, I'm going to tear it off and put it to the side. Now it says, make sure we're drawing on the sheet labeled foci 1AA. So this is the sheet I'm looking at currently. Okay, foci 1AA. Now let's go to my third step. Place your loop of string around the two push pins and keep the string tight. Use the string as a guide to carefully draw an ellipse around the push pin. So what we're trying to do is, based on, if I pretended that I have an ellipse, I'm creating an ellipse, and my two foci that I'm choosing are this A and this A, then when I draw it, I just want to see what my ellipse looks like. So make sure for this step you have your foam board ready, and you can get this from your teacher, and put this page 7, on top of your foam board. Okay, and now secure your foam board by putting 2 push pins on top of it. And since my foci are A and A, and those are my foci I'm choosing, I'm going to put 1 push pin on A and 1 push pin on the other A. These push pins represent my foci and the distance between them. I'm pretending that one of my foci is always the sun, remember, and the other is an imaginary point, and this will help me figure out how eccentric or oval shape my orbit will be if this is the distance between my foci. Now that I have my foci and I look back over here, it says to place a loop of string around it, keep the string tight, and then make an orbit or ellipse. So grab your string. You should be provided this as well, and make sure this loop of the string is away from your thumbtacks or push pins. And I'm going to place the string around my push pins. What I'm trying to do is I'm trying to create an ellipse around my 2 foci to see how elliptical it will be. And what I'm going to do, I'm going to take my pencil and stretch it out a little bit, very gently, to just make sure that it's kind of straight and it always is stretched out a little bit. But you might need several tries to do this part, but just make sure you have a gentle hand, okay? And what I'm trying to do is I'm going to keep stretching my string very gently, and I'm going to create this circle around my 2 foci or thumbtacks, kind of like this. Now if you mess up, keep going, keep making that circle, and just erase the extra edges that you messed up in after. And here you go, I have an orbit. Now what I'm pretending is this circle is my orbit, my planet going around the sun, which is any one of these foci, and the other focus is just my imaginary focus. And yeah, I'm just figuring out how elliptical the shape of the orbit of my planet will be if this was the case. Okay, now I have this. And now after you've drawn the ellipse, remove the push pins. Let's do that. And now it even says over here, 1 foci will represent the sun, just like any other planet orbiting the sun, and the other foci represents an imaginary point in space. Label this ellipse 1. It's already labeled for you, so you don't have to do that. Now for number 5, it says measure the distance between the straight pinholes of foci. The distance between foci is in between, and record this on your report sheet. Now, and then it wants us to measure the length of the major axis and also record it on the report sheet. And finally, it wants us to calculate the eccentricity and put it on the report sheet. When it's talking about the report sheet, this is what it's talking about on the next page. And what we're trying to do is find the distance between my foci, find the length of my major axis, and find the eccentricity. Okay, so let's see. Remember, if you go on the first page, and this is on your reference table, eccentricity is the distance between foci divided by the length of major axis. So the first thing I need to do is find the distance between my foci. And remember, in this case, my foci are A and A. Okay, so I just need the distance between them. And for this, I'm going to be using a ruler, and I'm going to be using the centimeter side of the ruler because my answer, as you can see, needs to be in centimeters and also the nearest tenth. So I'm going to take this and I'm going to place the 0 of my scale at 1A and just see the length from 1A to the other. And I'm seeing that this is around 1 centimeter in length, my distance between foci. Now, your answer might be different from mine. As long as it's 1 centimeter, plus or minus 1 centimeters from mine, it should be fine. So I'm going to go back to my report sheet and write 1 centimeters. But notice it says nearest tenth, okay? It needs to be nearest tenth, which means I need one number after the decimal. When anything asks for nearest tenth, it's talking about, if this is just an example, 1 and 1 number after the decimal, okay? And if it's anything's asking about the nearest thousandth, then a nearest thousandth would be a number and 3 digits after the decimal. This is tenth, this is thousandth. So I can't just write 1, it needs to be to the nearest tenth. So I'm going to write 1.0 because I need 1 number after the decimal. Now the next thing I need is a major axis length. And remember, the major axis length is from one side of the circle to the other side of the circle, and it needs to go through my foci. So I can create a line to show you. I'm going to make sure I'm going through my 2 foci, A and A, and I'm going to create a line. Okay, my length of major axis would be from this side all the way to this side, right here and here. So let's find it. I'm going to start with my 0 on one side like this. And if I look closely, my length of major axis is around 18.1 to, I'll go with, let's see, I'm going to try to look a little closer. I would say I'm going to just go with 18.2. Okay. Now remember, your answer can be plus or minus 1 centimeters from mine. So 18.2, just one number after the decimal, and I have that. Now I need the eccentricity, which is the answer. And I need to show my work in the calculations. So I just need to do 1.0 centimeters divided by 18.2 centimeters. And that gives me 0.055. I just need 3 numbers after the decimal because it's to the nearest thousandth. And remember, eccentricity has no unit, so I'm just going to leave this number like this, 0.055. And that's it. That's my eccentricity for ellipse A. Now, you need to do the same thing for ellipse 2 and ellipse 3, and you'll find it in the next pages. Keep this one on the side, don't lose this page. But if you look at the other pages, page 8 and page 9, you'll find one for foci BB. And for foci BB, you do the same thing. You put it on the foam, but this time you put your thumbtacks on B and B. Create the circle like I did before, and then do the calculations for ellipse BB. Okay, and then you do the same exact thing for the next one, page 9. I'll rip it. But this time it wants it for the foci CC. So I'm going to put my thumbtacks for this time on C and C like this, and then make the circle and then do the calculations. Afterwards, you're going to be comparing these ellipses, your answers or calculations, and answering these analysis questions, okay? And that's it for now. Thank you.